Hello, everyone. Today, we're diving into the world of square numbers, a simple yet fascinating concept that's more than just multiplying a number by itself. So, what exactly is a square number? A square number is the result of multiplying a number by itself. If you multiply 2 by 2, you get 4. If you multiply 3 by 3, you get 9. That's why we call them squares. They represent the area of a square with sides of equal length. And that's how it looks geometrically. A square number literally forms a perfect square. For example, 4 is 2 squared, 9 is 3 squared, and 16 is 4 squared. Now let's take a look at some cool properties of square numbers. Here's a fun fact. The sum of consecutive odd numbers always equals a square number. For example, 1 plus 3 equals 4, 1 plus 3 plus 5 equals 9, and 1 plus 3 plus 5 plus 7 equals 16. The pattern continues forever. Here's a legendary story. The mathematician Carl Friedrich Gauss, when he was just a child, used his brilliant mind to add numbers from 1 to 100 in seconds. While he didn't use square numbers directly, he recognized patterns that are related to how numbers can be organized, including squares. And square numbers themselves play a big role in math everywhere, including in the famous Pythagoras theorem. Here's something even cooler. If you add 2 consecutive triangular numbers together, you always get a square number. For example, 1 plus 3 equals 4, 3 plus 6 equals 9, and 6 plus 10 equals 16. It's like triangular numbers are the building blocks of square numbers. Some numbers can also be written as the sum of 2 squares. For example, 50 can be expressed as 7 squared plus 1 squared, or 5 squared plus 5 squared. Here's a fun one. Some square numbers are palindromes. They read the same forwards and backwards. For example, 121 is 11 squared, and 484 is 22 squared. Did you know that some prime numbers can be expressed as the sum of 2 squares? This amazing fact is part of Fermat's theorem on sums of 2 squares, and it's one of the coolest connections between prime numbers and square numbers. Fermat's theorem states that a prime number can be written as the sum of 2 squares if and only if it's of the form 4n plus 1. That means the prime number has to leave a remainder of 1 when divided by 4. Let's take the prime number 5 as an example. It can be written as 1 squared plus 2 squared, because 1 squared plus 2 squared equals 5. Another prime number, like 13, can be written as 2 squared plus 3 squared, because 2 squared plus 3 squared equals 13. But not all prime numbers can be written this way. For example, the prime number 7 doesn't fit Fermat's rule because it's of the form 4n plus 3, and it cannot be expressed as the sum of 2 squares. Thanks for watching. If you found this video on square numbers interesting, make sure to follow us. See you in the next video.